So remember I said this. So we had y prime was a y, right? And I said one way we could do this is we could like look at this and go, duh, y is e to the at, right?
Yes.
But the categories are wrong, because the only way I know e to the at is to say, okay, let me just do the power series expansion for e and shove at in it. So that'd be like the identity, or this kind of, I'm really looking at this and thinking like that's a really big one, right? And then I do plus at plus at squared over 2 factorial plus, oops, a squared t squared plus a cubed t cubed over 3 factorial, and kind of on and on. And if I got lucky, right, like if my matrix was nilpotent or something, this would stop eventually and I could be done. Or if there was a pattern I could observe, like if say A was a diagonal matrix, you could find a pattern that would be pretty obvious, right? So if I got lucky basically with the form of matrix, I could make this work. But this thing categorically is what kind of object?
It's a square matrix.
Yeah, it's a matrix, specifically a square one, right? It's a matrix the same size as A was. You guys see that? So this statement doesn't even make any sense, because that's a vector and that's a matrix. So what the hell?
Well, it could be a matrix getting multiplied by a vector, right?
Yeah, so you need to multiply by a vector. And that's also kind of like, dude, there should be a constant here, right?
You had that.
I thought we had a vector.
Yeah, and I said we should put that constant on this side,
Yeah.
because I was teaching out of an old book in my head where a row vector made sense. But you guys have vertical vectors, right?
Yeah, usually.
Like, I told you guys to use vertical vectors, and so your vector has to go on this side. So your constant has to go over there.
That way the insides match, right?
Yeah, just because this whole thing here is kind of an n by n matrix,
And
right?
we want it to be an n by whatever.
And this is an n by 1 vector. And so that multiplication will actually work, right? Because the kind of
That's
n's drop out, you end up with an n by 1 vector. If you guys, had done that other thing, where I said you put the constant on this side,
You can't even do that,
Yeah,
right?
you can't.
It's
yeah,
not
this would
allowed.
be a n by 1 vector times an n by n matrix, and that doesn't make any sense. What was going through my head there was the last time I taught this, it was out of a book that
1 by
did
n.
row matrix or row vectors instead of column vectors, and so this would have made sense.
Is row
So-
vectors any easier? Or is it just pretty much the exact same?
No, it's the exact same thing, but upside. Like you just have to cock
it's like
your
landscape
head.
and portrait, except for vectors and row.
Yeah, exactly. It's just a different representation. It just forces you to cock your head at everything. And the reason I was happy with this book was that it's column vectors, which makes life a lot easier to translate to linear algebra. But for some reason I hadn't switched my head around. So it should be constant comes second. And that constant is actually just a vector of your initial condition. You guys see that? Like if you plug in y evaluated at 0, you're going to get e raised to the a times 0.
That gives us a zero matrix or whatever.
So yeah, this guy here, that exponent, is the 0 matrix. Which if you plug that in this expansion, you get I plus 0 plus 0 plus 0 plus 0, which is going to give you I. So you just get I times the vector c, which would give you c. Right, so that c is literally just a vector of the initial conditions that you have, which makes your life super easy. Right, because you don't have to solve for the constants, you just shove the initial conditions in there. Life is good. Cool? Alright.